All right, let's talk about one of the most important topics for the exam also, which is Amazon Bedrock. So this is a service around generative AI, which is essentially providing us with a platform to build and scale our generative AI applications. Here we get access to various so-called foundation models from all of the different leading AI providers, and this allows us to quickly integrate them and deploy them without the need to manage all of the infrastructure. So here are some of those important options and features that we have available. So first of all, we can choose from a variety of different foundation models that are offered, for example, by Amazon, A1-to-1 Labs, Amazon, offered by Amazon, Stable Diffusion, or Medas Llama, Amazon Titan, which is Amazon's own large language model, and of course Claude and so on. So all of those models can handle different types of data like text, sometimes embeddings, some are multimodal, and we have different types of use cases. Additionally, we have also a high way of customization and fine-tuning available. So we can customize the models with our own data, we can add our own knowledge bases, we can also tailor them specifically by fine-tuning the models, so we can configure the different parameters, and this is all possible to make this more custom. Additionally, also we have the serverless environment, so this means that we do not need to worry about the underlying infrastructure. This also includes, for example, some automatic scaling, then also, of course, the maintenance, and we can very easily deploy and manage those models without creating, for example, additional instances or setting up some very complex pipelines, some very complex storage. So this is all integrated in this infrastructure. And of course, also in regards to the data security, data protection, this is of course here also ensured that the data, including also the prompts that we might pass along to our models and also the model responses, they all remain within the same AWS region where the API is called from. Also, of course, the data is encrypted both in REST and also in transit. And about the pricing, we also have here a quite flexible mode of pricing available. Here we have actually two different ways. The first one is on demand. Here we can just pay only for what we are using without any time-based commitments. So here the charges are determined by the number of input tokens that are processed and also the output tokens that are generated from the model. And of course, also, for example, if we use an image model, then also, of course, the number of images that are generated. And as a quick note, the tokens are basically the fundamental units that the model is using so that this can understand what is the input, and then also, of course, the output will be generated in those tokens. So essentially, it is like words, but not exactly like a word. So for example, one word can consist of multiple tokens sometimes as well. But these are the building blocks of the model essentially. The second one is in regards to the pricing, the provision throughput mode. So here we have just a option for large and more steady workloads. So here users can buy basically units for specific custom models or base models, and like this we get a certain number of tokens that are processed per minute. And the so-called custom models can actually only use this mode. So this mode ensures that we have a very reliable performance, for example, for more demanding tasks when this might be necessary. While we are using Amazon Bedrock, we can get use of the following benefits of also other AWS services. So for example, for monitoring, we can use AWS CloudWatch, which can be integrated. Also for auditing, we can use AWS CloudTrail. And of course, in S3, we can store and manage larger data sets that might be used for the training or the fine-tuning. And also, of course, for the generated outputs, we can also store them in S3 buckets. We can even use Amazon SageMaker to enhance our models. And also we can use agents in Amazon Bedrock. We will also have a look at this in a bit later, so that's a bit more advanced. And those agents can make our applications do more complicated tasks and also be a bit more accurate when we have some very custom and special needs or some special information that are needed. So those agents, they can automatically break down the tasks. They can also connect to other data in the company through APIs. So they can make API calls. We can like this get some real-time data, do some actions, and then this can be integrated into our application as well. So those agents can add essentially very important details and functionality so that the answers and the overall performance of our application can be improved and extended. And there are also knowledge bases. So they provide our models and our agents also with information from, for example, some more private data so that we can get better responses also using this data. And this is also manageable and this is also customizable to what extent the knowledge base, and we can also customize this a bit to what extent we want to actually make use of this knowledge base. So while those knowledge bases, they focus on storing and augmenting the model. So this is a RAG-based application, so retrieval augmented application, because it can enrich basically our model and it can make it more accurate, get better responses. So we have just additional relevant data to enhance the responses. And on the other side, the agents, they focus more on executing tasks and breaking down tasks and managing the workflow. So they handle more complex tasks. All right, now let's have a look at why we should choose Amazon Bedrock. So let's quickly summarize those benefits. So firstly, we have a very efficient way of building our model environment. Firstly, it provides an efficient model building environment. Here, users can securely access a variety of those foundation models just through a single API. And this is really streamlining the process of passing the prompts, receiving the responses. So this can be set up in a quite easy way, as we can see in here. And also, of course, later on, we will see how this works in practice. In Bedrock, we also have those playgrounds. So this works for text as well as for images. So here we can just have some more quick experimentation and model evaluation. And again, we will have a look at this, of course, also later on in this course. And of course, we will also have a practical look at this in a second. Additionally, also it offers a secure application development environment. So here we have a comprehensive data protection. Always the data remains within the given AWS region, and the data is also encrypted so that we can be sure that our privacy and security is maintained. We have AWS identity and access management, which can be also used for more fine-grained access control over our customized applications. So also, of course, we can use it for the Bedrock console, so we can define who has actually access to this. And lastly, we have lots of ways of customizing our experiences. Like we said, we can set up those agents to automate more complex tasks, and we can also fine-tune the models to improve the performance on very specific tasks. And like this, they are more effective for very specific and particular use cases. And now in the next lecture, before we have a look at this in practice, let's also quickly have a look at some specific use cases. Now in this lecture, we just quickly want to have a look at a sample architecture using Amazon Bedrock. So in this architecture that we quickly want to discuss here, we want to automate the product review and approval process for an e-commerce marketplace or some retail website. So here we will leverage computer vision using recognition. We talk about this in a second, and also natural language processing so that we can analyze the product image. We can extract relevant attributes and like this generate a detailed product description for our e-commerce platform. So first of all, how does this work? We have, of course, in the beginning, API gateway. So this is where we can have an input from, for example, an image, maybe a new product that can be accessed through an API. Maybe this is something where somebody has added maybe something to a shopping list. So here, as a quick explanation, Amazon API Gateway is just a simple front door for the application to access data or some kind of a business logic. So here we can send requests and receive them through this gateway. So these are our APIs that we can use here. It's not so important, of course, for the exam, this service here. But then we have also, of course, and then our image can be also sent to a Lambda function. So we won't cover here Lambda functions in depth, but essentially Lambda is a serverless compute service. So here we can just run code, simple code snippets, without having to manage all of the servers behind it. So we can execute the code just in response to an event. Like for example, here we have maybe something is happening, and then as a response to this event, maybe we have an image that is being sent or is arriving somewhere. Then we can have this function being executed. So it will be triggered and it will be executed. So in this case, it will receive the image, and then by executing some kind of a code in the Lambda function, we will then also send it to Amazon Recognition. This is what this Lambda function can then do. We can also make some modifications and execute any kind of code that we want. And then Amazon Recognition, this is also something we talk about at another part, is using machine learning to identify objects in the image. So it can recognize and describe these objects and then pass this information along to help creating this product description. Additionally, our Lambda function can then also continue to process, again by calling now a large language model that is hosted by using Bedrock. So here we can have, for example, a model like Amazon Titan. This is AWS's or Amazon's large language model to then create this product description. The model can also enhance, of course, existing descriptions or maybe generate new descriptions based on the objects that were identified by Amazon Recognition. Additionally, we can also fine-tune these models with some very specific business logic or some business data so that our product description will be more tailored with our own information. Or also we can create the content in a specific style, for example. And then we can also send back our output to the client so that our output can be used, for example, in the e-commerce website. And of course, also we can store the input and the output also as a response to maybe further improve or fine tune our model. So this can be stored then, for example, in an S3 bucket. And of course, we can also integrate Amazon CloudWatch so that we can improve the monitoring and the logging so that all of this is logged and monitored. Alright, this was just a little bit of an example of how an infrastructure could look like. Of course, for the exam, we don't need to be able to build something like this. This was just a little bit of a preview into how this could look like. So hope it was helpful, and now let's go and put this into practice as well in the next lectures. Now let's have a closer look at some of the more practical use cases of Amazon Bedrock. We have already seen that the key thing here is that we get a managed environment, easy access to the APIs where we can use all of those foundation models. We will see this also in a second, and then we can use it in our own applications. For example, something like this. Here we can send the message to the model. We can specify which model we are using. And of course, you don't need to know how this exactly works. You don't need to be able to implement this for the exam, but in the next lectures we will even quickly have a look at how this can be set up in a more practical way as well, just to have a little bit of a practical understanding here as well. So some of those use cases are around content creation, of course. We can generate dynamic content, for example, for marketing or maybe even entertainment. So all kinds of different use cases. For example, also in customer support, we can develop advanced chatbots or virtual assistants, and we can automate some repetitive support tasks just to improve the efficiency with our specialized application. But also for data augmentation, we can create synthetic data for training of other machine learning models. So we have here also our own custom application that is doing this so that we can improve our other models. So we get some enhanced data sets and so on. And this is also a potential use case for such of for such applications. Also, we can use it, for example, for product recommendations. So here we can personalize product suggestions based on, for example, the user behavior. And of course, for some e-commerce platforms, this might be a very suitable case to enable some more dynamic content here as well. So you see that Amazon Bedrock is offering a very comprehensive solution for integrating generative AI into various applications. We can have a secure, scalable, and efficient model deployment and maintenance of the environment, and everything will be fully managed for us. And therefore, let's now quickly also have a look at a sample architecture of Bedrock, how this could work. That's what we quickly will be doing in the next lecture. And then we, of course, dive into this in practice. In this lecture, we now want to have a look at Amazon Bedrock and how we can use it. So I will search for Amazon Bedrock and we will see how we can use that to create applications using all kinds of large language models, because we want to build some applications, but sometimes it can be tricky to set this up in an environment. We have many different tasks to do here, and Amazon Bedrock basically just provides access to those models in a very easy way in a managed environment. So here we have access to models like Llama or Titan, which is actually AWS's own model, and we can use those different models for text generation, for image generation, and build our own applications with this. So therefore, in this lecture, we want to get an overview over Bedrock, and afterwards, we also want to see how we can set up our own application. So first of all, we search for Amazon Bedrock and then we can click on Get Started. And in here, we can already see that we have probably this pop-up in here where we can manage the model access. This means we first need to request access to those models before we can actually use them, because sometimes we need to agree to some agreement, and then we are only able to use them. I will just close this window because we also have the option for model access in here. And here we will see the list of all of those base models. And here we can see, for example, Amazon, we have Titan Text G1 Lite, G1 Express, and so on. So these are just different types of text models or also image generation models. Some of those models are available and some of them are not available. For example, Llama 2 is not available anymore. And also note that this depends which types of models we have available in here, which location we have used. So in this case, I'm using US East 1 because this has the most of the models available, and therefore we should select here US East 1. And in this case, we could enable all of the models, but we can also enable only some specific models. For example, we would like to have access to the Meta models and also to the Amazon models. And maybe later on, we can also enable here Stability AI. So here we can also check just the ones that we are interested in. So I will just have now Stability AI, Meta, and Amazon selected, and then I will click here on Next, and I want to just have now access to them, and I can submit this like this. So here we have now requested access, and all of this has been granted. So we just need to do this in the beginning so that we actually have access to those models. And now what we can do is step 1, we can have a look into the playground. So in the playground, we are able to test the model and play around with some of our prompts, with some of our parameters. And then later on, when we go into the examples, we can also see here some code, how this can be used in an application. And also we will be able to now later on implement this then. So first of all, let's go to the playground as we have said. So if I navigate to chat, I can select a model that I have access to. So in this case, I can see I don't have access to this one. So let me select maybe Meta. Here I see I have access to those two models. So in this case, I could also try maybe with the Titan model. So here I will use, in this case, the Express model. I apply it and then I can use it and test it now. So here I can now just enter my prompt. So for example, I can say, who is Einstein? And also I have the configurations on the right side. So here with the temperature value, we can just, like it says, the randomness and diversity, we can control some of this fine tuning. And this is a mathematical parameter that is just determining the model. And essentially, in simple words, the temperature, if we have it at a lower value, it is a bit more determined and a little bit less random. And in a similar way, we can also configure this top p-value. So with those two values, we can just control the randomness and the diversity. So we have to test around with this. And here, this is the one that is important for us. So here we have the response length. So if we use 179, this is then cutting off after 179 tokens, because we are paying here based on tokens. So therefore, we have this as an important property to control the prompt, how this is configured. So I set this to a relatively low value. I've entered my prompt, and then I want to just submit this, and then I will get the response back. So here we can see this is the short response, as we have suggested that as well. And here we can see now the model metrics as well. So like the latency, the input token count, the output token count, and also the cost. Because of course there is a cost associated with this. Where can we find about the cost? We can get more information about this cost when we go to the model itself. So in this case, we can find it, for example, under overview or also under base models. And in here, I can, for example, search now for our Titan model. And in here, this was the light version, and we can just open it from here as well. And if we scroll down, we see here under pricing that we can have a look at all of this pricing. Essentially, this brings us just to Bedrock pricing, where we have an overview over the different models. So for example, if we have a look at the individual models, we can see those prices here per 1000 input and 1000 output tokens. So for example, here for Amazon, we see the Titan models, and here we can see this is the price for text light. For the input tokens, this is what we insert as our prompt, and then here these are the output tokens. This is essentially the response per token. And you can roughly think a token is not exactly one word. So usually we have multiple tokens for one word, but sometimes one token is one word. So roughly you can say that 1000 tokens are around 750 words. But this is just a rough estimate and can also depend on the model. But just to get an idea about the amount of tokens here. And now we can see, of course, in the playground, let me go back to the playground, where we can select now this model. Now I want to choose, for example, again, the same one, and I might want to compare it with another model to see which one is more suitable. So maybe I want to now compare it with this one, and I want to ask a question like, for example, what is the capital of Canada? And now I get the response in both of those models, and I can see maybe one of them is faster than the other one. Here I can see Express, as we expected, is faster, and here we see the input tokens and then also the output tokens and also the price of those prompts and how we get the price of those prompts and responses. So now, of course, we might want to use this in our application. This is what we are here for, and therefore in the next lecture, we will see how we can set this up. So what we want to do, we want to demonstrate this, and don't worry, you don't need to be a Python expert, even though we are using Python. So therefore in the next lecture, what we will be doing is we will install, first of all, Visual Studio Code. We will quickly set it up. Then we have to set up a user in our AWS account so that we can also have somebody that has access to those models, and also for billing purposes, of course, we need to have this enabled so that this is connected with our Visual Studio Code has basically access then to with our user. We can configure this so that we use the command line interface to have access to AWS. And then afterwards, we can use one of those models and build our own application. So of course, this is something that we will demonstrate at a lower level because we don't need to know about this in the exam, but we anyways want to give a little bit of practical understanding, and we want to demonstrate here some of those concepts. So this is what we want to do in the next lectures. If you want to work along with me, you can now also go ahead and install Visual Studio Code. And in this lecture, we just quickly explain how this works. So essentially, I'm just searching for Visual Studio Code. This is the first link that appears. And here we have also this download option. Even if we click on this main option, we can also find Visual Studio Code. So in here, I just reject this. We can also find the download option up here. So essentially this brings us just to this URL. So if you don't find this download button, you can also directly go to the URL or just search for download and you will also find it. In my case, I'm using a Windows machine. So therefore I will download the Windows installation file. In your case, of course, if you have a different operating system, feel free to use the different installation files. In my case, I now download just here Windows. I will save it on my machine. And after it has been downloaded, I can just execute it. So I just open the installation file and then this should open up here, this installation wizard. So here, of course, we accept the agreement and then we just click through this installation. Here we can leave it all at the default settings. And then also in here, if you want, you can create a desktop icon. I don't want to do that. And also the other options I just leave at the default. And then I click through and click here on install. And then after maybe a minute or so, this has been installed. All right, you see, it is pretty easy. So now we have completed this setup and now we can also leave this box here checked and then we click on finish and this will then immediately launch Visual Studio Code. And now in the next lecture, let's continue with the setup in here. So in this lecture, we now want to start to set up Visual Studio Code so that we can invoke a model from Visual Studio Code. And we will see a couple of examples. And first of all, of course, to be able to do this, we need to connect to our AWS account. So therefore, on the side of AWS, we will create a user and we will also have to install a few libraries in Visual Studio Code. And we will see how this works. But be sure that this is nothing that you actually need in the exam. So we will use some Python script and this is quite technical, which I just wanted to demonstrate to give you a feel for how this works and just demonstrate this in a practical way. But be sure that nothing of this is really needed for the exam. So if this seems too complicated, don't worry, this is not needed for the exam. So let's get started with setting up Visual Studio Code. So step number one, we want to set up a folder. So in here, we can put our files, we can use them. And to do this, we can just navigate here on the left side to open this Explorer. And here we find Open Folder. By the way, you also find Open Folder in here and also under File, you can also find Open Folder. So I will just click here on this button and then I can navigate to a folder that I want to use. Here we will put our file that we will then execute. So this will be our Python file, the script that we will use. In my case, I just navigate to a location. Here in this case, I have already created this folder. You can also create a new one. I will just select it and select this as our folder. And in here, we can now get started by creating a new file. We can do this by clicking here on this plus icon for a new file. And in here, we will create a Python file. I will call this titan.py. So this is the Python ending. And then I just hit enter and we call it Python because later on we will actually use here, if we are in Bedrock under examples, this Titan model. And here we will see some example where we are summarizing some meeting transcript. So in this case, we just call it Titan so that it is clear what we are doing in here. But before we do this, we need to install a few libraries. So first of all, to be able to do this, we can also toggle the panel down here, and then here under terminal, we can install first of all two things. So we can do this by using pip install, and then we want to install Bodo 3. Bodo 3 is just the Python SDK so that we can interface with the AWS services. And then after we have done this, we will also install pip install, and then we use AWS CLI. So this is just the command line interface so that we can interact with our AWS services. So this is something that we also need to do so we can run the commands to, for example, list S3 buckets, or in our case, just invoke the models that we will invoke. So we have installed now both of this. And now, of course, we need to configure it because we are not connected yet. We just have installed the library. So what we can do is we can run the command AWS configure. And then when I do this, I should be able now to provide an access key ID. Well, where do I find this? I have to set up a user for this. So therefore, I will now navigate back to my AWS account. And here we can search for IAM. So here we find IAM, and here we are able to set up a user. We can grant the permissions and then also generate this access key. So we will navigate first of all to users. And here I have already created a user before. We can just click on create user. I will just give this a name, maybe Nikolai admin, something like this. We can just click on next, and we can also attach a policy directly. For the sake of this demonstration, I will just grant here administrator access. This makes it just easy. Of course, if you use it in a productive environment, be more fine granular with the access in here. I will be fine here though if I use administrator access, and then I click on next. And now we can go ahead and create this user like this. So this is what we need to create the user. We can now open this user, and in here we will see the access key. So we can now create this access key. I do this by just clicking on create access key. This will be for the use case of command line interface. This is what we will be using. We click on next, and we also have to confirm that we understand the recommendation. So we are aware of this. We click on next, and now we can give a description. So I can say something like, let's say Titan model. This is just a descriptive value so that we can remember this. And then I can go ahead and create the access key. So now we need to be sure that we can, that we copy this access key, because once we have created this, so we could, for example, download this as a CSV file. And of course, we have to make sure that this is in a secure location. So because once we click here on done, we won't be able to use this or to see this secret access key. Then we just had to create another one, but then if it's already used in an application, it might be tricky. So therefore, we are only able to see this once. In our case, this is fine though. So first of all, anyways, I will just copy the access key. So in this case, I will paste the access key here. I hit enter, and then I have to provide the AWS secret key. So now this is the one that we find from here. I can also just copy this. I could, save it somewhere, but it is fine in our case. We just copy it, paste it, and of course, I will also delete this afterwards so that this is not visible and that this doesn't work anymore. So this is, of course, what we have. And then here, I can also change the default region. And in our case, we anyways wanted to use the region US East 1, because this is where we have access to the models. So therefore, instead of using US East, I would just say US East and then 1, so that this is our default region, and the output format JSON is fine. So we leave this at JSON, and now we have this set up. So now in the next lecture, we want to see how we can create a first script to invoke a model. This is now what we want to do in the next lecture. Now let's have a look at how we can invoke a model and use Bedrock in this environment. We have now set up everything on the side of Visual Studio Code, and on AWS, we now want to again navigate back to Bedrock. So I can just search here for Bedrock, I can open it, and now I want to have a look at some of those examples that we have also already seen a little bit before. So I navigate to the examples. In here, I can find lots of different examples. I can also filter it. Of course, make sure again that you are in the correct region, US East 1. Here, we should have access to the models. So we can see this under model access. And in here, we should have access to at least a couple of models. And in this case, also the Amazon models. So therefore, I will go now to the examples. You can filter again by Amazon if you want. And then here you have now this example. So again, this is just an example. Here we have some configuration. We see how we can modify this. We have here a sample prompt. We can also see how we can modify this. And this is essentially what we have. So the other use case will just be a little bit different in the sense that the prompt is a bit different. Here maybe this configuration is a bit different, but we will see that this is how it works in general. And here we have, by the way, also a response. So this would be in this case the response. In our case, we want to use the first one. So I select here action items from a meeting transcript, and don't worry if your example looks a bit different. This is, as we have said, not a problem because it is just an example. So if you have this available, select it, and then we can scroll down to the code sample. So in here, again, this looks a bit confusing maybe, and this is not a Python course. Don't worry, we don't need to understand how this works exactly, but we want to demonstrate this, and I want to explain this just very roughly. So in general, this is how it works. And even if we have another use case, this is still the structure how this works. So therefore, I will copy this sample code, and now we will go to Visual Studio and paste it in here. So now let's see how this works. We have already previously installed Bodo 3. Now we want to import it. This is just again the AWS SDK for Python so that we can interact with the AWS services. Afterwards, we also want to import the exception from Bodo Core so we can handle errors that are related to our AWS service calls. And then afterwards, we want to create the Bedrock runtime client. So in this case, it is just the client for Bedrock runtime. The region we have set to US East 1. And then we want to just set here, in this case, the model ID to Amazon Titan Text Express V1. This is just the model that we want to use in this example. And then afterwards, we prepare our user message. So here we just use a multi-line string, and we just have, in this case, the transcript of the meeting. And this is our example. So here we use this transcript in this multi-line string. And then afterwards, we have here the structure of the conversation input. This is just how the structure is expected from the model. So this is just what the model expects. We can find it here from the example. And in this case, it is just structured in this format. So here we have the array, and then we have the roles where we have the user, and then the content, which is the transcript. So here we just use this user message. This is essentially our prompt. So here the user input from this conversation is just our prompt. And then here we have just inserted this that we have stored before in user message. And then afterwards, we will now attempt to send the message to the model. And then also afterwards, here this is accept, we want to catch any errors that might occur during this process. So now let's have a closer look at the message that we sent to the model. So again, this is just what the model expects, and some other model could have a little bit of a different structure potentially. And we can find this, or this is why those examples are very useful, because then we have this already set up in here. So essentially what we are doing, we are just calling here client converse with a few parameters that are expected. So here in this case, this is the model that we use. We have the message in the format, and then here the tokens the max tokens. So we can say we want to have maximum, let's say maybe 196 tokens. So like this, again, we remember that we pay by amount of tokens. So if we want to, maybe save a little bit cost, we can reduce this in here. And then afterwards, we can also include some stop sequences. So in this case, it would be user. We can also modify the temperature and the top p-value. So these are just the configurations for our model. So I could say, well, I want to use maybe a value of 0.3, and maybe here I would like to use a value of 0.8. And then afterwards, we can just now extract and print the response text. So essentially here, this is just some nested object, and here we want to just extract the text information. So this is why we store this item here in response text. And this gives us essentially just the response, so just the text that will be returned. Because in here, in this response object, there are a couple of things included that are not really so relevant. So therefore, we are only interested here in the text, and this is then what we will print. And then if there are, of course, some issues, we will also be able to throw this error message. Okay, so this is it. Now we should be able actually to make this work. So first of all, we see this is not saved by this little circle. So I use Control S, and then afterwards I want to run it. So I can do that, for example, by clicking this play button, or I can also use here in this terminal. I just click in here, Pi, and then I say Titan. This is the name of the script, how we have called it, titan.py. I hit enter, and then it will execute, and we will see if there are some issues or if this actually works. And in here, we can indeed see a list of action items for each person based on the meeting transcript. And of course, if we would have here some different content, then the response would also be different. So let's say we have maybe this removed. I again save it, and now I want to execute it again. So here I just click in this line again. I can also press the up arrow so that we see again the previous command. I hit again enter, and then maybe it is now a bit different. So now we have maybe fewer people, and therefore we will have a different response. So here we can see now it looks quite a bit different. So this is how we can invoke a model in Python. And of course, this is the structure that is used. And if we use a different model, then this looks maybe a little bit different. But hope this demonstration was helpful, and see you in the next lecture. In this lecture, we now want to try to also generate an image. So in this case, we will use this generate variations of an image example. And again, if you want to create something like this, you could always open it in the playground, play around with the inference configuration so that you know how you would like to have it, how you want to have it configured. In this case, we will see how this works. And of course, we can then adjust also this configuration if needed. So therefore, let's see how we can do this. First of all, we want to copy again the code from this example. And by the way, you can also again just filter it to Amazon, and then you should be able to find somewhere here some image generation. So in this case, we could use this generate image from a text prompt, and I can go down, I can copy this, and in here I can now go ahead and paste this into a new file. So in Visual Studio Code, I will create a new file, and I could just call it, for example, image.py, something like this. It doesn't really matter. And then I paste in the code in here. So again, we will import here a few different libraries. So in this case, we can have access to all of this. And again, we need to make sure that the region is set to 1. In this case, we have the model ID to Titan image generator v1. And here we can also insert the prompt. So this means that we can use a different message here. So for example, I can say I want to have a green backpack on a chair, for example. You can use something different if you want. And also here we want to format this request payload so that it is in the correct structure. And in this case, I will also insert actually this text in here. And then afterwards, we will see that we can also now invoke the model. So this works in the same way. So we just use the request where we have just created this JSON dump out of our request, and then it can be fed into the model. Okay, so how this works is now we just want to save this image to a local folder, and then we can see this in this local folder. So I will just set this up like this, and then we can also save it. So here there's just some decoding in place, and then it will be saved to our location, and then we get also this message with this path. Okay, so this is actually all that we need to do in this case. I will again use Ctrl+S to save this file, and then afterwards I can now again go down and use py, and I say image.py, and then this will be created. So we see no such file or directory. And in this case, I just noticed that I used a little bit of a different name. So it is called image.py. I will execute it, and then I wait until we can see the response. So I can have a look into this folder, and in here I see now this folder output has been created, and I can find indeed here this image. So I can open it and I can see that this is what has been created. In my opinion, this actually looks pretty good. So this is pretty cool. And now if we want to do this again, we can again just run this. We could also modify our text. So in this case, I can, for example, say green backpack on a beach, maybe let's say on a tropical beach. I can also put that here into our prompt. So in here I say this is the one. So I paste it in here. I again of course have to save it using Ctrl+S, and afterwards I can just again execute this. So I can see that this will again generate now another image. And in this case, I can now see, if I again navigate to this location, I open this file, and I can see indeed that this is a different image of a green backpack on a beach. So this is pretty amazing, and we have seen that this works. And so this is pretty amazing, and we could see that this is pretty easy how we can create this. And some of the things that we could improve, of course here, for example, we can just also use the prompt actually, so that we don't need to copy this all the time. So I will just remove this, paste this in here. Also here we have some parameters, so we could structure this a bit nicer. We could also use here different width and different height. Of course, we have to make sure that we use actually parameters that are acceptable for this model. But we could, for example, try to use in this case maybe something like 512 and also again 512. And then we can say that now we want to create something like, for example, in the jungle. So a green backpack in the jungle. Let's use it like this, in the jungle. Let's again save it, Ctrl+S, and we want to execute it again. And in this case, we can see now we have another image created. This is now in the jungle. And I think also this looks actually also pretty good in my opinion. And lastly, we have seen that actually here we have generated 3 images. But we have only processed one of those images. So here we see we have only used the first one. So we could actually save all of those images, and then we could loop through also saving all of those other images. So I just remove this in here, and here we could also then call this image data list, because here we have 3 images. And in here, we can then just replace this part to also save all of those images. And in here, we just use an image and a for loop to do essentially the same thing, but now just for all of those images. And again, don't worry, this is very far away from what you need to know about the exam, but I just wanted to demonstrate that this actually also works. So now, after I have saved it, I will try to see if this has actually worked and if we now have 3 images. All right, let's have a look at the output folder. And I see that now we have those 3 images again. Of course, in this case, it has overwritten the previous ones, but we can see now the output from all of those images. Okay, so this was the demonstration about using image generation using AWS Bedrock. Hope it was helpful, and see you in the next lecture.